Hello, my name is Blais. I'm a research scientist with the Ottawa Laboratory Carling of the Canadian Food Inspection Agency. The research and development section of the Ottawa Laboratory has been very busy developing new test methods to enhance the capacity of our food microbiology testing laboratories to detect, identify, and characterize foodborne pathogens. As a tool for the transfer of technologies from the research lab to the food micro-testing laboratories where these methods are to be implemented, the laboratory has developed a series of videos that will highlight some of the critical steps involved in performing these different assay procedures. The visual representation that will be provided in these films will go a long way towards helping analysts to perform the methods correctly and to identify areas that might require their special attention. In this second video, we will now demonstrate the procedure involved in the hybridization of PCR product with an array of immobilized probe, as well as the procedure for the assay of hybridized products on the cloth strip and the colorimetric visualization of the final result.
Place probe-coated strips in individual Petri plates. A pencil or waterproof permanent marker can be used to label strips with dots corresponding to the sample number. The hybridization solution containing 50% formamide is prepared by mixing 1 part 2 times hybridization solution with 1 part formamide. This solution should be ice cold. It is recommended that this solution be prepared and placed on ice prior to the denaturation of the PCR products. Transfer the dig-labeled PCR product into a 1.5 milliliter screw cap microcentrifuge tube. Denature the dig-labeled PCR product in a heating block at 100 degrees Celsius for 10 minutes. After the denaturation period, snap chill the denatured dig-labeled PCR products by immersion in ice for 5 minutes. Centrifuge the tubes for a 10-second pulse to bring down the condensate from the caps. Return the tubes immediately to the ice. Referring to the protocol, add the ice-cold hybridization solution containing 50% formamide to the denatured PCR products. Mix well and saturate the cloth strips with the corresponding PCR product mixtures. Cover the plates and incubate the strips at 45 degrees Celsius plus or minus 1 degree for 15 minutes. Manipulate cloth strips using tweezers. Rinse the tweezers in a small beaker containing water or PBST buffer between each treatment. After the hybridization step, strips are washed 5 times by saturating the strips on the filtration apparatus with PBST. Apply vacuum suction between the washes. PBST can be prepared in a large volume, for example 8 liters, and stored at room temperature for up to 1 year in a carboy fitted with a spigot for ease of use. While the vacuum is still on, remove the strips from the filtration apparatus. To prepare the anti-dig peroxidase solution, mix the antibody with PBSTB in a 1 in 2000 ratio on the day of the experiment. PBSTB is a solution of PBST containing a percentage of blocker. This solution can be prepared on the day of the experiment, or alternatively, a large quantity can be prepared ahead of time, dispensed in falcon tubes, and stored in the freezer for up to 1 year. As an example, mix 1 microliter anti-dig POD with 2 milliliters PBSTB. Saturate the strips with the prepared anti-dig peroxidase solution and incubate at room temperature for 10 minutes. After saturating the strips with anti-Dague peroxidase, strips are washed 5 times by saturating the strips on the filtration apparatus with PBST. Apply vacuum suction between the washes. Saturate the strips with tetramethylbenzidine membrane peroxidase substrate and cover the strips with aluminum foil to protect from light. Let the color develop for up to 10 minutes. Formation of a distinct blue spot on the chast strip coinciding with the appropriate probe is considered a positive reaction for the appropriate gene. The negative and blank controls should only produce a color reaction with the IAC probe feature. The results of the chast test are not considered valid in the absence of a color reaction with the IAC probe on the array. Failure to see an IAC reaction is evidence of either 1. Inhibition of the PCR by sample matrix contaminants, 2. Failure of one of the detector reagents, or 3. Omission of a critical component in the procedure, for example, the PCR reaction mixture.